Here is another question. This is again dividing an x power n by a number. The way we are going to approach it is a variant because some of these questions require the second method to solve them more effectively. Believe me, we are nearing the end of the reminders concept, right? We've done quite a lot of this. For those of you who by now are like wondering, is there more in reminders? We're almost at the end of it. What is the remainder of 5 power 60 divided by 17 is the question. We'll as usual start by listing down the reminders for different powers of 5 starting from 5 power 1. 5 power 1 by 17, remainder is 5. 5 square, 25 by 17, remainder is equal to 8. 5 cube, 8 into 5, 40 is remainder, which is actually equal to 6, right? 8 into 5, 5 square into 5. 40 divided by 17, the remainder is equal to 6. 5 power 4, you can plug it a couple of ways. 5 cube into 5. 5 cube, the remainder is 6. For 5, the remainder is 5. So it is 6 into 5, which is equal to 30. 30 cannot be the remainder, so let's make it as a 13. 5 power 5, the remainder is 5 power 4 into 5. This is a 13 into 5, which is equal to 65. 17 into 3 are 51, so this is going to be equal to a 14. The next step is 5 power 5 into 5. This is 14 into 5, which is equal to a 70, which is equal to a 2. The next step is a 5 power 6 into 5. This is a 2 into 5, which is equal to 10. Looks like, see, 5, 8, 6, 13, 14, 2. We haven't seen anywhere the pattern repeating. Theoretically, we could have 0 to 16, 17 possible values that the remainder can take. So for all you know, the pattern might repeat at the end of these 17 steps, in which case we are in for a long haul. There is one way to find the answer. Let's also look and see if the negative reminders can come of use. Here the negative reminders are all much bigger than the positive reminder. Probably one place where it is smaller is a minus 4, this is a minus 3, this is again bigger. Here it is equal to minus 7. None of these seem friendly. Let's just go one more step. This is 5 power 7 into 5. This is a 10 into 5 into or 10 into 5, which is equal to a 50. 2 into 17 or 34, this is equal to 16. At least somewhere, some hope in life, we have reached a minus 1 here. Right? So computing negative reminders helps us, but look at it. We have found the negative reminder at the 8th step. Let's proceed with this. Let's see how to make sense out of it. Let's not try to find what is a pattern. The pattern will obviously be emerge at the 16th step, because if 5 power 8 is a minus 1, 5 power 16 is going to be minus 1 into minus 1, which is a plus 1. I'm going to go along that way, but without using pattern. 5 power 16, the remainder is the remainder of 5 power 8 into 5 power 8. For a 5 power 8, we were lucky to find that the remainder is minus 1. So in this case, it's minus 1 into minus 1, which is equal to plus 1. I'm not going to see how many 5 power 16. The cyclicity, I'm not going to worry. Because listing down all of this is a pain. We'll check out down the line how we can cut down a lot of these steps. I'm going to write a 5 power 60. The power 60, let's start with this. I know a 16 leaves me with a remainder of 1. 5 power 16 leaves me with a remainder of 1. So I'm going to break this 60 as some multiple of 16 plus something. So we'll write it as a 16 into 3, because 16 into 4 makes it a 64. We have only a 60. 16 into 3 is a 48. 48 plus 12. The 12, I'll choose to write it right now as a 16 into 3 plus, I don't want to find out for a 12. I already know it for an 8. So plus an 8 plus a 4. So I'm going to write this 5 power 60 as a 5 power 48 plus 8 plus 4, which will essentially become 5 power 16 whole cube into 5 power 8 into 5 power 4. All that we have learned with indices, we are putting it to good use here. 5 power 16, the remainder is 1. So 5 power 16 whole cube, the remainder is going to be 1 cube. 5 power 8, we computed the remainder to be equal to a minus 1. Let's use that here. 5 power 4, let's go with the negative remainder. It's a better remainder in this case. So this is equal to minus 4. So the final answer is equal to a 4. So the gist of what I'm trying to impress upon is, try and compute reminders. But when you find that sometimes the divisors are such a large number, in the earlier questions that we did, the divisors were 7, divisors were 8. These all had remainder values which are less than 10, which essentially meant that the number of steps required to find the pattern is also within a count of the fingers of your two hands. Whereas a 17, it could end up repeating once every 16 steps or 17 steps, in which case we'll take about 7 minutes, 6 minutes to solve this question, which is not how we should go about it. This is a better method to go about it. Just captured whatever you have discussed in a typewritten form. I'll rerun it there, so it becomes a little clearer there. Right? This is what we have. We listed down the reminders. We found out we couldn't reach a pattern, but we found a -1 at the 8th step. So the moment we got a -1, we know we can use that to put it to good use. 5 power 8 divided by 17, remainder is -1. So 5 power 16 divided by 17, it's actually nothing but -1 into -1, because 5 power 16 is a 5 power 8 into 5 power 8. So we know that for 5 power 16, the remainder is 1. So we are trying to write this 5 power 60 as 5 power 48 into 5 power 8 into 5 power 4. So which is 5 power 16 whole cube into 5 power 8 into 5 power 4. Plug in the reminders for this. The remainder for this portion is a 1 cube. The remainder for 5 power 8 is a -1. In this case, I've taken it as a 13. Actually go for a -4. Makes life much easier. So remainder is equal to 4. What we'll do is, we'll see if we can cut down some more steps. This is an iteration which will reduce some more steps. We went to a 5 power 8 to realize we had a -1. Let's not even worry about whether we are going to get a -1 at the 8th step or the 9th step. Let's just stop at 5 power 4. What is a 5 power 4 remainder? Which is equal to 13. Now, what will be the remainder for 5 power 8? A 5 power 4 equivalent remainder can be written as a -4. So, for a 5 power 8, it's going to be -4 into -4, which is a 16, which translates to a -1. From that point forward, we are going to proceed this way. So, I didn't compute for 5 power 5, 5 power 6, 5 power 7, 5 power 8. If it were not a -1, I still would not have worried. Whatever is this number, I would have squared it to find out the remainder for 5 power 16 and proceeded along that line. So this is what we'll have. So steps are, for 5 power 4, it was a -4. 5 power 8 became a -1. So 5 power 16 is a 1. Then proceed along the same lines to get to the answer that we had, which is equal to a 4. We'll cut this step by one more. We'll stop at finding out the remainder for 5 square. The moment I have a remainder for 5 square, I'm going to say the remainder for 5 power 4 is 8 into 8, which is equal to 64. 64 with the divisor being 17. 17 into 4 is 68. This is 4 short of it, so I can write this remainder as a -4 at this step. 5 power 8, the remainder is -4 into -4, which is equal to 16, which actually translates to being a -1. From this point forward, we have done it in the earlier steps. We'll just proceed along the same way. So this is what we have as the answer. So gist of it is essentially realize that once you get a -1 or +1, life becomes easy. But you need not always look for a -1 or a +1. If you find that the divisor is a large number, in those instances, compute the remainder for 5 square. From there, move on to finding out the remainder for 5 power 4. Skip to a 5 power 8 from there, square this. Go to a 5 power 16, and if required, a 5 power 32. And then, whatever number is given, for example, if you have a 5 power 73, you can write this power 73 as a 64 plus 9. 64 plus 9, 9 can be written as an 8 plus 1. Look at this. All of these numbers that I have written are all powers of 2. So, it is sufficient if you compute the remainders for powers, which are powers of 2. So, that's what I've stated it here. So, compute remainders for a square, a power 4, a power 8. The simple reason being that any positive integer can be expressed as the sum of powers of 2. I'm driving home this point with one more example. 3 power 48, what is the remainder when it is divided by 19? I used Microsoft Excel to compute this, so I'm not going to cheat you saying that I computed it. Realize that it repeats at the 18th step. 19th step is where it repeats. The pattern repeats once every 18 steps. 3 power 18 is the first time you're seeing a 1. Till then, all of these values are different. Imagine you get a question of this kind and you try to approach it using the pattern method. You've been slaughtered. That's the only word I can use. Let's use the variant. Let's check out how it works out. 3 divided by 19. The number is 3 divided by 19. Remainder is equal to 3. 3 square. The remainder is 9. I'm not going to compute for a 3 cube or anything. I'm just going to jump to 3 power 4, which is 9 into 9, which is equal to 81. 81 divided by 19. 19 fours are 76. Remainder is equal to 5. I have a 3 power 48. Let's check out where it takes us. So 3 power 8, the remainder is going to be 5 into 5, which is a 25, which actually translates to a 6. 3 power 16 is a 6 into 6, which is equal to 36. Again, quickly, 19 into 2s are 38. So the equivalent negative remainder is a minus 2. Get directly to the negative remainder. Don't even bother computing what the positive remainder is. This is a quite of easy number to work with. A 3 power 48 is nothing but 3 power 16 whole cube. For each 3 power 16, we know the remainder is minus 2. So for a 3 power 48, the remainder is equal to minus 8. If minus 8 is the remainder, the equivalent positive remainder is add a divisor to it, which is going to be equal to 11. So this, I'll just go back to the previous slide. If you had got it this way, from this point forward, you would have said 3 power 18, the same as for 3 power 36. Now what do we have? After 3 power 36, we need to go 10 steps, we need to go 12 steps to reach 3 power 48. That remainder was 11, which is how we got it, which is the same answer as this. But how many steps did we calculate? 1, 2, 3, 4. The fifth step gave you the answer. So every time, use this variant method when you find the divisor is a large number. Probably the test maker the guy who said the question, is hinting to you saying that don't use a pattern method. You're going to not find a pattern so easily. Whew. We covered quite a bit in this video. It's a lot of concepts to cover in one single video. Time you took a break. Use the break for two things. 1, subscribe to this channel. And 2, sign up for the most comprehensive and affordable GMAT Quant course that's available online at gmat.visaco.com.